I'm tired of AI tech sounding generic, so I fine-tuned an open source AI model on every YouTube transcript from this channel on my own home lab over one weekend. Did I actually manage to build my own fine-tuned AI that sounds like me? Well, that's what you are going to find out in my honest guide to AI fine-tuning. In this first video, you will learn the basic mechanics of fine-tuning, how it is different from just prompt hacks, and why learning the skill can make you a valuable AI engineer. Because honestly, almost nobody knows how to do this properly. So let's just get right into it. Now, to show you the effect of a fine-tuned model, let's have a look at what my home lab returns for a simple question when I ask it to an open source Qwen 3.5 model. And the system prompt here just says you are Zen, showing that, just to illustrate here, that I'm not cheating and adding a bunch of information in between. The only thing I'm going to do is ask a question. How do you stay up to date with the latest AI tools and frameworks? Now, with Qwen 3.5, the default behavior, you can see right here is that it just starts to think very deeply about every single question you throw at it. Even though this question is pretty simple. If you were to ask it to me directly, I can give you an answer in 2 seconds. I don't need to think for 12 seconds here. We're just spending so many tokens just coming up with a huge explanation of what Qwen 3.5 might be thinking, and now it's coming up with this extremely strange answer. A question about flow and change. In truth, I do not chase the new as you might. I mean, this is like almost poetic, but this has nothing to do with how I would describe how I actually use AI agents to learn new AI concepts. That's the truth. That's the real answer that I would give. It's talking about community as a mirror, rest and stillness. It's not even worth reading this slop. And you can try to guide this model with a better system prompt, but in the end, your system prompt is not going to cover every type of question that you might throw at a model. Whereas if you fine tune it, you really just implement your own persona into a model like this. Let me show you what I mean. I'm now going to unload this model and load my fine-tuned 27B Qwen 3.5 model. It still says Qwen 3.5, but you can see here that this is my custom model. It's almost 18 gigabytes. I'm going to go ahead and load it, and then I'm going to just start a new chat, and I'm going to paste the exact same question, and let's see what this fine-tuned model now responds. That's it. It doesn't start thinking because I've explicitly fine-tuned it and disabled thinking. And now it just says, I use an AI agent to scan through all of my saved resources, notes, articles, videos, and pull out everything related to the topic I'm working on. That way, I don't have to manually dig through folders or remember where I've saved things. It's a lot faster than trying to recall what might be relevant from memory. Now, of course, this part here, you might disagree with, right? It's a different way of working, and maybe you think that using AI agents for any type of memory is just bad for your brain. But at least it's interesting. You can have a conversation about this with me because it's my real honest answer. It's getting this from some transcripts where I described my second brain system in a previous video. Granted, there's a couple of M dashes that I personally wouldn't use, but that's more of a stylistic change. The focus on the fine-tuning of the model was really to represent my tone of voice and my persona, which really comes through in a couple of aspects. Not just the answer itself, but also that it was just quite brief. It's not a poem response to a very simple question. That was just very direct, just like how I am as a person. So when it comes down to it, what actually is fine-tuning? Well, with fine-tuning, what you do is you take a base language model. This could be a small open source model or a really big one. In any case, what you end up doing is creating a LoRA adapter. This is a tiny trainable adapter that you create with your own training data. And it's an adapter because essentially what you're doing here is you're not retraining the entire AI model. You're just basically injecting some different parameters into the model. If you end up doing this, you can create your own fine-tuned model, which is the base language model, but then fine-tuned to, for example, your personal voice. You are not going to be retraining billions of parameters. Very often it's enough to train, say, half to 2% of the parameters of the model. And this is a big advantage because, as you'll see in my later videos, this means that if you augment even a small set of data, you will likely be able to fine-tune pretty decently sized open source models. But when do you really need to fine tune? Because there are a lot of AI platforms out there that claim train on your data, but they don't really do that. A lot of them just inject your information into a prompt. And that's not a problem because you can get pretty far with that. And in fact, injecting into a prompt or using something like RAG, Retrieval Augmented Generation, is a lot simpler than fine-tuning a model. especially because you need a lot of data engineering, maybe even data scientist experience to do it properly, not even talking about the hardware you need for it. Well, let's actually go through three different scenarios. Let's say that you're considering to just prompt your model or implement a more standardized paradigm like RAG, or of course fine tune. Well, when do you just want to inject some information into a prompt? This is when you have a one-off task, experiment, or a quick tweak, which is kind of like just using something like ChatGPT yourself, where you start a new chat, you have a prompt, you get an output, and that's kind of the end of your system there. For example, summarize this email in 3 bullets. The cost of coming up with this technical solution is free because you're just writing plain English and that's it. However, a lot of real AI use cases require more than that. For example, let's say you're building some kind of customer support system for business, or you want to gather knowledge across an organization and ask any question about it. Well, that's where a lot of paradigms like RAG, retrieval augmented generation, come in, where you have all of your knowledge structurally stored in a certain way, whether it's in a regular database, a vector database, which I've talked about plenty of times on my channel, or otherwise, and you're able to pull out that information according to what a user is searching for. And then once you found the right information, you inject it into the prompt. Now, in that sense, it's similar to the prompting approach, but there's just more of a system behind it. And if you do something like RAG, you can use an AI system even if facts change. This is how language models like the latest ChatGPT model are still up to date with the latest world knowledge. Even though they have a clear training cutoff date, which might have been half a year in the past, they can execute web search and retrieve information themselves and self-inject that new information into their prompts. And this way, a model can be kept up to date without having to actually retrain it. But this is not limited to just public web information. You can also store your private documentation in such a database. And RAG has been here for a couple of years now and has been very effective and is still a very effective method because it's pretty much low, right? The cost. It's something that you can find many tutorials on. In fact, if you check out the link in the description below, RAG projects are part of my free local AI projects that you can get used to. And it's still something that's relevant today because unlike more difficult agentic solutions, RAG is almost free depending on how well you set it up. So then what really is the use case for fine-tuning? Well, the problem with both prompting and RAG is that you can guide the model in certain ways. For example, do you remember when all of these AI models used M dashes everywhere? Well, you can solve that by prompting the model to remove M dashes, but that only gets you so far. And there's a reason why AI-generated posts on LinkedIn and platforms like that still sound so robotic, because you can try to prompt your way out of a lot of things, but eventually you will just run into the behaviors of the language model based on how it was trained. So if you need something much more novel and tuned to your style, which is one of the goals of my own fine-tuning project, then fine-tuning can be a great solution because you're actually baking in knowledge and a style inside of the model directly. And some example use cases could be to create a model that writes like you every time with a real guarantee. Or you can make data that doesn't change so often, let's say laws that have been in place for years, part of the actual open source model, and then use RAG for any laws that might have changed since the last training date, thereby increasing the model's performance on a very specific task. Now, that sounds very powerful, but fine-tuning is not easy. It will cost you at least a weekend of screwing around, and you need a pretty competent GPU to do this. If you're not entirely sure whether you need fine-tuning for your use case, you can use a super simple flowchart. First, you can just try a better prompt and evaluate whether the model performs well enough on a task. If that fails, you can add RAG. If that fails, you can consider an agentic loop where the language model itself gets to decide whether it needs to pull in more information or even ask another agent to help itself out. That being said, agentic loops are pretty difficult to get right, but if you need some inspiration, you can of course look at how platforms like Claude Code are being built right now. If that still fails, well, then it's probably worth fine-tuning. And fine-tuning can also be a great opportunity as well to have your own in-house model to really have an edge over competitors who are just prompt injecting everything. So what does a real honest fine-tuning pipeline look like that you can find on my channel in the next coming weeks? Well, the interesting part about this is that it's quite multidisciplinary. You need different types of engineers to work together to make a really good fine-tuned model. And so if you learn this kind of pipeline and you can follow all of these steps, then you can become a very competent AI engineer. I would say that for your first fine-tuning project, there's roughly 5 steps. The first step is data collection. In my case, I'm collecting YouTube transcripts, but for your use case, you might need to collect logs, documentation, examples, and you need to measure how much data you actually have. Let's say that you're training an 8 billion parameter model, you might need a million, 2 million plus tokens of raw data, and that's before you've transformed the data. Next, you will need to do some dataset engineering. You want to clean the data. For example, my YouTube transcripts, they contain some weird spelling errors because the automatic transcripts from Google aren't perfect. And I want to clean them because if you don't clean your data, then all of those bad behaviors and bad text output will be part of the fine-tuned model as well. It's not like the language model is able to self-correct that. If you feed it bad data, then actually you're going to make the end result much worse. So you need to do dataset engineering and spend a lot of time to clean and format the data. But also you need to manipulate and change your data so that you have pairs of prompts and responses. In my case, if I just have a transcript of my YouTube video, that's not really in the right format to train or rather fine-tune a language model. The reason for that is that if you imagine how you use ChatGPT or Claude, you might ask it a question like, where can I find the nearest bookstore? But you don't literally just start from nothing and then generate a transcript. Usually you interact with these language models using a chat format. And when you're fine-tuning, you need to correspond with that chat format as well. So what you'll see in some of the later videos is that I have a pipeline set up that transforms my transcripts. So let's say in one of my videos, I say, I use Fast API to build Python solutions. Well, then I can use a local language model to generate a question that is relevant for that little text snippet. For example, a relevant question could be, what is a great framework to get started with when I want to learn Python? And then my Fast API answer is a logical answer to the question. And so if you use a language model to create many of these different pairs, you will be able to properly fine-tune a model. And the way that you do this dataset engineering really depends on the end use case of your fine-tuned model. Let's say you want to create a model to write blogs. Well, in that case, you might want to always have prompts that go something like, you must now write a blog 4 with a paste prompt of some kind of news article. And then you're going to have a bunch of responses that actually correspond to your desired blog format. Formatting rules that are part of your responses will be embedded in the model as well as you fine-tune it. So this is already pretty difficult. Data collection, dataset engineering, it's easy to skip over it and just use something like Claude Code to vibe code your fine-tuning pipeline. But if you don't get this right, you're going to have a very poor fine-tuned model. So let's imagine that you spent the time to do this right. What's the next step? Well, now you want to go ahead and do LoRA training. LoRA stands for low rank adaptation, and I can give you a half-hour lecture about what that really means, but there's a reason why you're watching this YouTube video and you didn't sign up for a PhD in machine learning, so I want to keep it brief but accurate. With LoRA, what you're able to do is instead of fine-tuning all the parameters of a language model, you can fine-tune just 0.5 to maybe up to 1.5%, which means that you need much less training data. But also, the training data that you do need will go through the fine-tuning process much faster. So instead of having to wait 20 hours to get a result, maybe you can get some fine-tuning done in just 2 hours and iterate and fix any problems you have. You will learn more about LoRA as we go through the entire series, but for now, this is all you need to know. It's a much more effective way of fine-tuning because you simply have to retrain less parameters of the model. And here you're going to be using your hardware to its full potential to fine-tune a language model. And this can take quite some time. It depends a lot on your hardware, the type of model you're training, but then also, of course, the parameters that you set. To give you some kind of benchmark, when I created my fine-tuned model on medium-sized language models, it would take something like 2 to 3 hours on my 5090. So you can imagine that if you set the parameters wrong, you're going to waste a lot of time here. So now let's talk about the type of hardware that you need to fine-tune. When I created my models, I ran tests for a smaller 9 billion parameter Qwen model, a medium-sized Ministrol 3 model, and then a pretty large Qwen 3.5 model, 27 million parameters. And the reason why I say large is not because it's the largest open source model out there, but because you need pretty good hardware already to fine-tune this kind of model. Because when it comes to the amount of VRAM you need, well, something like a 27 billion parameter model likely will exceed 14 gigabytes. And 14 gigabytes is if you're lucky and you're using a more efficient version of the model. Now, What kind of hardware you need also depends on the vendor that you choose, what kind of computer you buy. Here's the thing, NVIDIA is just the leader when it comes to being able to fine-tune quickly and easily, because NVIDIA GPUs have access to CUDA, which is essentially a software development kit that makes it very easy for software to interact with the GPU very efficiently for fine-tuning. You don't have to write CUDA scripts yourself. There's Python libraries, for example, that you call, but that is basically what's happening under the hood. And NVIDIA has a clear competitive advantage to this, but that's also why their GPUs can be quite expensive. In my case, I use an RTX 5090 to train these three models, but it's not a very cost-effective option. In fact, if you're going to go the NVIDIA route, you might consider buying some second-hand GPUs. Some NVIDIA models can even be paired together to combine their VRAM. But in any case, it's very important to realize that you need quite a lot of this video RAM in order to even fine-tune a model in the first place. There are some party tricks that people might talk about where they're using some of the regular system RAM to offload parameters, but this will grind fine-tuning to a halt, and sometimes that just doesn't work at all. So you really want your GPU to have access to dedicated memory. So if you want to use a competent GPU, but you don't want to pay the NVIDIA tax, how about AMD? Well, the great part is that AMD is actively developing CUDA counterparts. With ROCm, you can actually fine-tune quite a lot of models already, but because it's not really the first party compared to CUDA, your mileage might vary. That being said though, if you're just here to create a hobby project, if you've got an AMD GPU lying around, you might as well try and see if you can make it work, but it has to be a pretty recent one. And I'm making this orange because, as I said, it's not really a first-class citizen when it comes to fine-tuning. It's just much easier and there's much more compatibility with NVIDIA GPUs. But I'm making this video today, and if you're watching it a year from its release, maybe ROCm has caught up in a lot of ways. So AMD is definitely worth considering here. What I would definitely avoid is to fine-tune on Apple silicon. Now, don't get me wrong, I think Apple hardware is really good for using AI models, because if you've got a MacBook with, say, an M5 chip, and you've got 48 gigabytes of RAM, the great part is that because of the silicon architecture, you can use almost all of that 48 gigabytes to run AI models. You can run a pretty large language model. However, fine-tuning this model requires specific model versions to be released in an MLX format. And the honest truth is that a lot of models don't have that because the model developers don't bother to create such a port, as they assume most people will, for example, be fine-tuning on an NVIDIA GPU instead. And I also don't really expect the situation for Apple Silicon to get much better in the short term, because even if a model did have an MLX port, fine-tuning on a silicon chip is likely going to be much slower than on something like a really good NVIDIA GPU, because people talk a lot about whether or not the language model fits on the GPU, but just because it fits doesn't mean it runs fast. It might take quite a lot of time to get any kind of response from a large language model on a silicon chip, let alone the time it would take to fine-tune one. So if you've got the money to spare, NVIDIA is still the ultimate way to go. AMD is something that you can consider as a middle ground, and then Apple Silicon is pretty much in red. Now, interestingly enough, there are a lot of counterparts to Apple Silicon that AMD and NVIDIA are releasing. For example, you have NVIDIA Sparks machines, which also have this unified memory architecture, and those might become viable alternatives to getting a really expensive main NVIDIA GPU. In general, when you're looking for those kinds of machines with unified memory, be critical and double check some benchmarks that someone has ran on whether or not these machines are capable enough for fine-tuning. So this is why understanding how fine-tuning works is very important for you to be able to succeed in this. Next, of course, evaluation. You want to write some proper tests to figure out whether your fine-tuned model is actually performing better than the vanilla model that's untrained. Because this way you can evaluate whether you got something wrong in the LoRA training pipeline or maybe your dataset engineering. I've had many painful moments where I realized that I didn't transform my transcript in the right way, and that was thanks to my evaluation pipeline. And once you get better at fine-tuning, you will understand where the fault lies in your training process. Lastly, you want to do a GGUF export. And this is a format of a model that's easier to run on platforms like LM Studio and Ollama. And this is a lot more consumer friendly, so you can actually run your fine-tuned model wherever you want. In the next part, we're going to be talking about how I collected all of my data to fine-tune my own AI model, but you don't have to wait to get started. Check out the link in the description to get some of my local AI projects so you can get learning today. And of course, subscribe to the channel so you don't miss the next one.